So we can have three possible outcomes. We can have one solution, no solution, or infinitely many. Write that down. One solution, no solutions, infinitely many. And it depends on what the lines do. Remember, when we're ultimately talking about systems, it's two linear equations, so it's two lines. Most of the time, the two lines would just cross at a single point, and that point is called the solution. Okay? So in this case, the lines have different slopes. So if we're solving, or if we're looking at our two equations and we notice they each have a different slope, then there's going to be one solution. And that most of the case, that's what's going to happen. And intersect at one point. We already talked about that. Now, every so often, the two lines are going to be parallel. Since they never touch, there's no solution. And these lines are going to have the same slope and different y-intercepts. So if you have a highlighter, or if you want to underline this, this is going to be the main point. One solution happens when you have different slopes. No solution happens when you have the same slope and different y-intercepts. And then sometimes you'll have two lines that coincide, overlap basically. And that means that the lines have the same slope again. So same slope as before, and they're going to have the same y-intercept. Basically, once we rewrite them, they're going to look identical. Okay. So we're going to focus in on this right now. We have four systems here, and all we want to figure out is, do they have one solution, no solution, or infinitely many? Like this one? All right. So let's start. We have all right. So let's rewrite these equations. What we're going to do is, right now they're not in slope-intercept form. They're in standard form, this format. Okay. And what we're going to do is we're going to take our equations that are in which is not helpful for determining slopes or y-intercept, and we're going to rewrite them in y equals mx plus b, which does tell us what's the slope and what the y-intercept is. Okay, so let's go ahead and start with that. Well, right now, like I said, they're in this format. We have to rewrite them. So I want you to take each equation, and we're going to just copy them down. Like this one will go here, 4x plus y equals 2. And then negative 4x minus y equals negative 2. Okay? So let's take these two equations and put them in slope-intercept form. We practiced this before when we needed to graph the lines. All right, so here we go. Let's take 4x and get rid of 4x. It has to go to the other side, basically. I'll show you how to do that. Subtract 4x on both sides. Okay? And what happens here is these two are opposites and they cancel. And let's see what we have. We still have y on the left side. On the other side, we have two different terms that don't combine. We have negative 4x, and we have positive 2, so we'll write it as plus 2. And that's all we need to do there. Okay? Let's move on to the second one. Again, we want to get y by itself. We have all of this stuff. We need to get rid of it, starting with negative 4x. And it cancels. All right. So now, be careful. I often see people just bring down y. But we have something besides y. We have the minus or negative sign. That has to come down. And we still have 4x minus 2 this time over here. Okay, we're almost there. This is y, so we're good. This is negative y. We need to remove this. Remembering what number really goes here? 1. In this case, negative 1. So let's divide out the negative 1. All right. And we've got y equals negative 4x, because 4x divided by negative 1 is negative. Negative divided by negative is positive. So this is what we have. Okay. Take a look and let's decide what this represents. So let's check our chart up here. Definitely the slopes are not different. They're the same. So it's one of these two. This is same slope, different y-intercept. This is same slope, same y-intercept. Which case do we have here? Same slope and same y-intercept. After you rewrite them in slope-intercept form, they should be identical, and they are. So this is infinitely many solutions. So if we were to graph these, we have infinitely many solutions. Okay. All right. I'm going to show you a little trick to speed things up for the next one. All right. Let's see. Again, they're in this format. We want them in slope-intercept. So we're going to take this one and bring it down here. And this one, we'll write it down there. Let's start with that. 9x plus 3y equals 12. Negative 3x plus y equals 7. Okay, write that down. Now, we got to remove everything that's on the left side except for y. Okay. Now, I want you to notice one thing. Here I had 4x on the previous example. I had 4x, and I subtracted it. And it popped up on the other side of the equal sign. Do you see that? But it's not 4x, it's negative 4x. Here I had negative 4x on the left, and I added both on both sides, and it popped up on the other side, but this time it went from negative 4x to positive 4x. So here's something to remember. It's like a shortcut. If you take a term like 9x, bring it over to the other side, what happens to that 9x? It goes from positive to negative. Whenever you move a term from one side to the other, it switches signs. That's going to happen each and every time. So if you're comfortable with that, you could say, you know what, I need to move this over. And what's going to happen is it's going to move over, but it's no longer positive 9x, it becomes negative 9x. And then the 12. Okay? So we can do that now. If you're comfortable with that move, you don't have to subtract the term on both sides or add the term on both sides. All right. We still have a little more work to do on this one. I want to get rid of just the 3. I don't want 3y. I just want y. So what would I do mathematically to remove it? It's being multiplied. So what removes it if it's being multiplied? What's the opposite? Divide. Let's divide everything by 3. All right. Y equals negative 9/3. Well, I could simplify that. 3 goes into 9 3 times, so it's negative 3x. 3 goes into 12. That's 4. And now it's in slope-intercept form. Okay. Let's see what the other one gives us. Let's use that trick again. Stop it. All right. Let's bring this over. What happens if when it hops over? Write down what you think. You got a pencil. If you're wrong, you can erase it. Okay. If it moves over, it goes from negative 3x to positive 3x. And this one's, we get an answer real quickly because do you notice it's already in slope-intercept form now? It has y equals. That's our goal. So all we had to do was move it over, and we have a slope and we have a y-intercept. So now let's make a decision. What do we notice about these slopes? Negative 3 and positive 3, are they equal? No, not equal. So which of these cases does it fall under? One solution. Different slopes. Even though they're opposites, one's positive, one's negative of the same number, doesn't matter. They're not equal. If they're not equal, no solution. You could just stop right there. Okay, so let's try this one. I'd like you to try that on your own. Take each equation, bless you, rewrite it, and put it into slope-intercept form. Let's regroup. So hopefully you saw that on this equation, bring over negative 2x, it becomes positive 2x, and y is by itself. Okay? Y is by itself. So that one's done. Our other equation, you bring over 6x, you get negative 3x equals negative 6. Negative 3y equals negative 6x plus 15. Well, we're almost there. We need to get rid of this negative 3 by dividing. So you divide by negative 3, and you get y equals 2x minus 5. So look at your slopes. They're the same. However, the y-intercepts are different. One's 12, one's negative 5. Right? So which case is that? When the slopes are the same, but the y-intercepts are different. Look at your chart above. Yeah, this is a no solution. Same slope, different y-intercepts. That's what we have here. So this is no solutions. All right. Let's do one more. Let's take one equation, work it here. And that equation, work it there. Try it out. So this is what we end up with. Two equations, and I'd like you to look what we have. And which situation is this? One, One solution, no solution, infinitely many. Focus on the slopes. Yeah. The slopes are the same, so it's either no solution or infinitely many. And the y-intercepts are different. So again, we're in the no solution territory. So this is also a no solution. Remember, for a one solution, we want different slopes. Okay? All right.